find the volume of the frustum. And that's referring to this large black object at the bottom here, which has effectively had the top part of its cone chopped off. So to find the volume of this, we're going to find the volume first of all of the whole cone, and then just take off this bit at the top. So if you remember, the volume of the cone was 1/3 times by the base, which is pi r squared, times by the height. So we're going to work this out for the whole cone first of all, and then take the little bit off the top and then subtract it. So let's go and do the whole cone first of all. So the whole cone will have 1/3, and the base of the whole cone will be this part here, so that's got a radius of 6. So that's pi times 6 squared times by the height of the whole cone. The height of the whole cone is 15. So we tidy that bit up. Might just do this on the calculator here, I think. So 6 squared times 15 divided by 3 gives us 180 pi. So the volume of the whole cone would have been 180 pi if we had the red bit included. So the other bit, the little red bit on the top, again, the same formula, but just slightly different values to be used here. So we'll be using 1/3, and this time we've got the radius of this part, which would have just been 4. And then I'm going to multiply that by the height, and the height of this bit here is just 10. Again, I'm going to stick that into the calculator. So I'm going to have 4 squared times by 10, and then divide that by 3, which is 160 over 3. So we'll have 160 pi over 3. Both of those should have actually been given units, which I've missed off, which is not good. So now if I want to find the volume of this part, obviously that's just going to be this value and subtract this value. And that will give me the area of the volume of the bit that I want. So volume in total will be 180 pi minus 160 pi over 3. And that will give us our answer. So 180 pi minus 160 pi divided by 3. And that gives us our answer of 397.9 to 1 decimal place. And that's centimetres cubed. We could have left our answer in terms of pi as well here by just multiplying this side, top and bottom of the fraction, by 3, and leaving the answer as something over 3. But I'm quite happy for it to be left like that. Find the volume of the frustum. Similar setup again here, so we're going to work out the volume of the whole thing and take the top off. The only problem here we've got, this is a quite a bit more difficult situation because of this unknown value here. But we've effectively got two similar shapes here, because the big one is just an enlargement of the small version at the top here. So if we consider the length scale factor, so 5 up to 8, well, that's just been multiplied by 1.6. So 8 divided by 5 is 1.6. So in effect, we've got a length scale factor of 1.6. And now what that also says is that x here times by 1.6 must be the same as x plus 9. So we can write that down. And we've got that x times 1.6, or just 1.6x, must be the same as this distance here, x, add another 9. That's because they are similar shapes. So we're just going to move this equation round and solve it. So we'll bring all the x's over to here. So 0.6x, if I take an x away from both sides, gives me 9. So then I divide both sides by 0.6, divide by 0.6. So x is 9 divided by 0.6. Could do with the calculator, but we can sort that out anyway because we know what 0.6 is 3/5. So it's 9 divided by 3/5. And if you divide a fraction, it's the same as turning it into a multiply and flipping the second one. So that's 9 times 5 over 3, or 9 times 5 is 45, divided by 3 is 15. So x is 15. Okay, so now we've done that, we can start to look at the actually working out the volumes. So again, as we did last time, we'll work out the volume of the whole thing, and then we'll just subtract from it the volume of the top part. So the volume of the whole thing, using the same formula as before, I'll try and squeeze this into a slightly small space. So the base obviously has a radius of 8, so it's a third pi times 8 squared times the height of the whole thing, which is now 24. And I'm going to stick that into the calculator. So we get 8 squared times 24, all divided by 3, which is 512 pi. And that's centimetres cubed. For the cone on top, I'm just going to substitute straight in. That's got a radius of 5. And it's got a height of 15. So I'll stick that in the calculator, and we get 125 pi. So when I come to put it all together, it's just going to be this one, take away this one. So volume will be 512 pi, subtract 125 pi. And we can leave that nicely as an answer in terms of pi. So 512 take away 125 leaves us with 387 pi. And that is centimeters cubed.